We're going to look at the concepts of a unit circle. So a unit circle is a circle that has a center on the origin. And when I mean the origin, I mean in the Cartesian plane, except it's not quite exactly the Cartesian plane because we will be using thetas for this, but again, it's still the xy. So right here in the origin, we're going to go out 1 unit. Basically, bring out to 1. And we're going to do that all the way around. I don't think that's a good circle, but pretend that this will make a perfect circle. I will use a circle tool. Oh, they do have one. I will use a circle tool to draw an actual circle, but for now, we are going to use these lines to denote that this is 1 unit. Okay, within this 1 unit, we're going to have what we remember as our special right triangles. So we're going to have a radius of 1. And from that, as the radius goes around in circles, it can actually create triangles on my radius equal 1 using the x-axis kind of as the leg. All right, so we're going to use the radius of 1, hence a unit, 1 unit circle. And with this, we will be able to tell our sine and cosine. So I'm going to come in here, adjust this a little, no, not that way. What is this? Yeah, adjust this a little. Like I said, they weren't exactly on. I'm going to draw that circle. I'm going to draw it in blue. Now we're going to get rid of this. And from here, that does not even look close. Let me do this one more time. That's close enough. There's my circle. And from this, I get to say that this point right here is 1, 0. This point right here is 0, 1. This point right here is -1, 0. This point right here is 0, -1. Okay, the unit circle is a circle that has a center at the origin and has a radius of 1. So again, from here to here, this is my radius is equal to 1. And any right triangle formed with the radius is as the hypotenuse. The length of the hypotenuse is going to be 1. Based on the right triangle trigonometry, again, because we're making right triangles coming down, we can now say this point right here is x, y, which this is the length of x, this is the length of y. That sine of theta, theta being here right here, sine of theta is going to equal the opposite over 1, so y over 1, cosine of theta, because again our hypotenuse is 1, cosine of theta is going to be equal x over 1, or just y, or just x, and tangent of theta is going to equal y divided by x. All right, so some concepts here on the unit circle or a unit circle. All right, going to our example for this. An angle theta. Let's delete this layer. Let's draw that circle again just to have it. That is not a circle, this is my circle. I'm going to draw this circle in this nice pale blue. All right, so an angle theta has the measurement of 60 degrees. I am going to use my ruler here just to keep this a little bit straight since I do have the ability to do that. 60 degrees is roughly there. I'm going to be using this orangish color for my angle. So it has the terminal side that intersects with the unit circle. So here we go. Here is my measurement of 60 and a terminal side right here that intersects with the unit circle. So it crosses right here. at x comma y. What are the values of x comma y? So we know that this is 60 degrees. It crosses here at x comma y. So we have to solve for what x comma y is. All right, so the figure represents the unit circle so that the radius is 1. We drew our reference angle formed by the drawing the perpendicular line from the terminal point of the angle theta in standard position to the x-axis. The hypotenuse of the triangle is 1. So again, we're looking at sine of theta equals y, cosine of theta equals x. All right, so we're now looking at a reference triangle of 30, 60, 90. We've seen these before. So this is a 30, 60, 90 triangle. And from before, what we have found is that one of the sides, let me get to my ruler again so I could have a straight line going down. I think that was like 89. 89, 90, or there. Straight line going down. This is our guy coming down, making that right triangle. We know that one of our legs is going to be half. The other leg is going to be the square root of 3 over 2. So the side across from the 60 degrees is a square root of 3 times shorter. Or this one's going to be the square root of 3 over 2, if you remember from our past explorations. This side is going to be 1/2. Therefore, we can conclude that the sine, I want to write that in yellow, and yellow did not show up, that the sine of 60 degrees is going to equal the opposite side here, or the y value, square root of 3 over 2, and the cosine of 60 degrees is going to equal 1/2. All right, so I'm going to come up here and I'm going to fill in my unit circle for this xy because this will show up again over and over again. So this is 1/2 comma square root of 3 over 2. Always wonderful to memorize this because we will be filling in this unit circle. All right. Guys, that does it for this video. It does ask about the 45 degrees in a triad. So let's talk about that 45 degrees really fast. I know this video is going to go on a little bit longer than planned, but draw my circle. This one's going to be a yellow circle. Get my line here. Try to get as close to 45 degrees. That looks pretty good. Right. So this is what happens when I try to draw it by hand. My lines come out so crooked. All right, there we go. Hope you like the sound effects. All right, so here, if you remember from a previous example, we determined with a 45-degree triangle that this leg right here is a square root of 2 over 2, and this leg right here is a square root of 2 over 2 with a radius of 1. So when we're looking at sine of 45 degrees, we are looking at square root of 2 over 2. And when we're looking at cosine of 45 degrees, we are again looking for the square root of 2 over 2. So this point right here is the square root of 2 over 2, comma the square root of 2 over 2. So now we have the 60 point here, 1/2, square root of 3 over 2. We have this point. We actually have this point as well. This was 0, 1. And we have this point here, which is 1, 0. The only point we're missing here is the 30-degree point. The 30-degree point is like the 60, except your legs switch. So this is going to be, you'll have the longer leg here on the x and the shorter leg as the y. So this is going to be the square root of 3 over 2, 1/2. Really quickly, the way I remember the unit circle, because again, yes, you will have to know the unit circle, is the way it counts. This goes 0, 1, 2, 3, and then 4. 4 over 2 would be 2, actually. 0, 1, 2, 3, and then this is a whole number 1. And then 0, 1, 2, 3, and then the whole number. So that is how I remember. It's just counting 0, 1, 2, 3. And then when we go around the unit circle, it all just depends on the sign, but it follows this 1, 3, 2, 1, 0, 0, 1, 2, 3, 1. All right. So there you go. There is your unit circle. And guys, if you have any questions, we're done with this example. If you have any questions or comments, please always feel free to contact me, and I'll catch you in the next video.